Hey everybody, good afternoon. We're really happy to have you all here today. It feels like it's been a minute since we've done a webinar, so we're thrilled to kind of be back in action here. Today we have our friend Terry Harris from Reliable Process Solutions. He is going to be talking failure modes of electric motors. Certainly a topic folks seemed really interested in, as we had quite a few of you register, so that's great. This webinar, of course, is in conjunction with our annual Lubruary event. Everybody kind of pokes a little fun at that, but we've, for, I don't know, 7 or so years now, kind of made a deal of having the whole month of February, or Lubruary, be all things bearings and lubrication. So it's the time we show our bearings some love. So we're kind of starting things off with Terry talking about the failure modes of our electric motors, and then we can kind of talk throughout the rest of the month about how we can impact some of those, of course, with good lubrication practices, using, of course, ultrasound for your lubrication programs and things like that. So just a whole month of kind of talking all these things. If you follow us on LinkedIn, or if you don't, you should, you'll see that throughout the month, we're also going to just be posting a ton of resources and articles. We actually just posted an article the other day that we wrote based on a webinar Terry did for us last year on effective lubrication storage, which is something he is very well versed in, and someone you should definitely talk to if you want to improve those processes. But so we've got an article on that, and we'll just be sharing a ton more resources. So if this is a topic you're interested in, definitely keep an eye on LinkedIn this month, and hopefully we will provide some good content for you all over there, and some good things you can kind of take away, and tips and tricks and things like that you can put to use to improve lubrication practices at your facility. Some housekeeping before I turn it over to Terry. So we are recording this. That's always a question we get. So we'll have it available for folks to view afterwards. If you've got to hop off early, or you've got a coworker who couldn't make it, we'll definitely have this for you. And we, of course, welcome questions. You can type those in the little questions box throughout the presentation. I'll toss things over to Terry if it looks like we need some clarification on a point before he moves off of it throughout the presentation, or of course we'll have some time at the end as well. And I don't have it on here, but just, the typical, we are doing this live, so bear with us if we have any internet or audio issues. We'll certainly jump on fixing those as quickly as we can, and hopefully dogs, children, etc. behave, because they are still all here in the house. With that, I am going to turn the screen over to Terry, and Terry will let you take it away.
Okay, thanks, Maureen. I'll get my screen up here. Hopefully everybody can see it.
Looks good.
Okay, good. Well, welcome everybody. And again, we appreciate UE having me on to do this webinar, but very important concept here with electric motors. I go to so many plants, I'll show you a few pictures where, electric motors fail, and they just think they just fail. And they usually fail because of something we did or something we did not do. So hopefully some of the points here, and I'll cover some of these kind of fast because I've got quite a few slides in here. But you'll have all this information from the webinar, and if you have any questions, I've got my email address here at the beginning, at the end, and you're free to email me anytime with questions. This is the question I ask a lot of people. How long should a motor last? And then the question, what makes them actually fail and wear out prematurely? So a lot of times people say, well, they think they should last 2 years or 5 years, but in reality, they're designed to last for over 20 years. If we do all the things correctly. So if you look at the components of an electric motor, and this is where we break the electric motor down into all these different components. So you have a rotor, we have a stator, we have windings and insulation, we have this housing, we have the fan on the back. And so that you can see a lot of different components here that can actually fail while the motor's in service. And sometimes these components fail while the motor's in storage. And we'll talk a little bit about that as we go through the presentation. But here we see a majorly failed motor, where the coupling bolts have sheared off, the bearing in the shaft was so hot that the shaft actually melted and bent to the side when it broke. So, a major failure here, which with predictive technologies, this should have probably been caught months before this happened. This one here is a picture I took of one of my customers, but this motor was sitting on the shop floor, and I asked why the motor failed, and they said it just overheated and stopped turning. Well, it overheated and stopped turning because you have all this product on there. The motor couldn't cool itself, was probably one of the reasons that it got hot and failed. So you see these kind of things in the industry quite often. Here's a large motor that was, this picture was taken at a mine down in Suriname, and again, large motor, but you can see lack of lubrication, some major water issues around the bearing, but a major bearing failure here. But as we look at, I always look at things in terms of RCM, where you have to define these specific failure modes, and I break this down to the actual component actually failing in the motor. So again, we can look at all these different components. But in articles I've written, there's over 50 failure modes of electric motors out of these 8 or 10 components. And I'll show you a slide where you can see a few extra components that sometimes we don't think of as being a failure mode, but there's over 50 failure modes of electric motors. And again, I'll cover some of the slides kind of quick today because I wanted to make sure we get them all in there. But I do have an article on this too. If you guys, if anybody wants the article, just shoot me an email. But again, if we break the motor down into some main components, we have the housing. We have the stator, we have the rotor, we have bearings, bearing seals I break down as a different component because sometimes that causes failure modes of our bearing. The actual bearing housing that the bearing sets in on the end of the motor can be a failure mode depending on how many times it's been rebuilt, how much the rotor's been out of balance, what kind of corrosion there is inside that housing. People don't think of the fan being a failure mode. I'll show you a couple slides about how that fan can cause some major failures of the electric motor when it's not working properly. Windings and insulation, shaft, and the fan guard. So those are the main ones I cover in my training. But if you look at this picture, we have this, this little gasket around the electrical junction box here. If that fails and we get moisture inside of here, some kind of chemical, that can cause another failure. Just all kinds of little things. One of the plants I went to, one of the maintenance guys pointed out, well, one of the ones you don't cover is a failure of the eye bolt. And so I asked the question, well, how can the eye bolt fail to cause the motor to fail? And he told me about picking a motor up had it about 90 feet in the air, and the eye bolt broke, and then the motor fell to the concrete deck. Well, that's a failure of the eye bolt that caused the motor to fail for sure. But again, explaining that, the eye bolts they stick in electric motors are just a malleable steel eye bolt. They're not rated. So if you're going to pick motors up by the eye bolt, you should buy a rated eye bolt, just to give you that pointer, because those are about the cheapest eye bolts you can buy, the ones they ship in there. And they're just kind of to move around the shop floor. They're definitely not designed to pick up 90 feet in the air. But if you think of the motor housing, sometimes we don't think of the housing, but improper installation can cause the housing can cause the motor to fail. Physical damage of the housing, corrosion, material buildup, which we looked at a couple pictures of material buildup on motor housings. But you wouldn't think of the housing, but if we do improper installation and we don't correct soft foot, we put that housing in a bind. And by putting the housing in a bind, we can actually cause the bearings to fail earlier. So an example of soft foot here, most electric motors, just about all of them, except for Toshiba, if you lay them on a perfectly flat surface, one or more of the feet will not be touching the surface. And if a maintenance person and doing reactive maintenance actually just tightens this down, we can put that motor in a bind. Or if we have conduit strain or some other kind of strain on the motor. So we can put the motor in a little bit of a bind this way, which puts pressure on the bearing housing. We can put the motor in a little bit of a bind this way with soft foot, which puts bearing stress, extra bearing stress can cause the motor to fail early. So we have to correct soft foot conditions or buy motors that don't have that extensive soft foot issue, which Toshiba makes a motor. Yes.
Oh, sorry. So just a couple questions popped in there that I think you should maybe address. So someone was asking, are you saying that the factory installed eye bolt is not rated for the weight of the motor?
Normally they're not. No, they're malleable steel eye bolts, and they're not a rated eye bolt. If you look on there, there's no rating. So I would suggest if you're going to use that eye bolt, to buy an eye bolt that's rated for that weight or 50% above that weight.
Okay, cool. And then you were talking about the soft foot issues, and then you were someone wanted clarification. Are you saying that those are issues except for on Toshiba motors?
Well, it still could be with the Toshiba, but Toshiba does grind all the feet of their motors off to within 1,000ths, and then it goes to the paint shop, and Toshiba actually guarantees flatness of all their feet to 3,000ths. None of the other motor manufacturers do that, and it's easy to test on a flat surface. You'll find that one or more of the feet don't touch. So if you don't break it, you put the motor in a bind.
Thank you.
Yep. You know, motor housing from storage, you know, I've seen motors at a number of plants in storage. You'll see a foot broke off, you'll see a foot bent, you'll see damaged wire connections on the housing. So storage of your spare motors, you know, taking care of them and doing some inspections on them is very important. Material buildup on the housing, I showed you a couple pictures of those in the beginning there. I'll show you some more as we go through here, but you know, if that housing needs to be clean so air can move across it, and the lower we can get that temperature on that motor, the longer the insulation will last. So I'll show you a picture of a motor here up in Canada that I actually cleaned the motor and the fan housing off, and the temperature, you know, on the front bearing dropped 35 degrees. And so, you know, for every 18-degree rise, you'll cut the insulation life in half. We'll cover that more later. Here's another one. This was a picture of one of my customers at a corn facility, and you can see here the motor's completely covered with corn starch or whatever this might be. But again, this motor failed in service, overheated, and failed. But again, this is a PM. That motor needs to be clean so that air can flow across it. Now the motor stator, this is the stator that actually the core of the windings. It consists of many layers of laminated steel, which help create that magnetic field to turn the rotor. Well, how can it be damaged? Physical damage during the rebuild process. And I've been at many mines where they actually rebuild motors. They'll pull the rotor out, change the bearings in the field, and the stator can be damaged. Contamination, corrosion if we get moisture or chemicals inside. High temperature, voltage imbalance is something that can destroy a stator just with the vibration created from voltage imbalance. Broken support, and sometimes your rewind burnout procedures will damage the stator. We'll talk about that one a little bit. But physical damage can happen at the motor rebuild shop. It can also happen, you know, at your facility if you're changing bearings on the rotor at the physical facility. And a lot of times this happens at the mine because sometimes you just can't shut the mine down long enough or get it back, so you change the bearings in the field. Contamination, you know, storage methods. I've taken motors apart that have been stored without keeping that grease cavity in the front full, and they're corroded, rusted inside. So again, we have to watch for contamination inside the motors, you know, during storage and in some applications where there's lots of water. High temperature, you know, high temperature of the motor, maybe a short circuit or maybe a fire or something or some extra heat around there can damage that stator. Voltage imbalance is one that we don't have. It's not a common problem here in the US, but I've been in plants around Africa and South America that are running off of generators and other issues they have. So you'll have voltage imbalance between the three phases, which can also set up vibrations in the stator and cause it to fail early. I put this chart in there just for your general information, but you can see the effects of under voltage and over voltage on the different conditions of your motor as far as efficiency, power factor, starting amps, and maximum torque. So again, so like I said, I stuck this in there, but look at it when you check it. And again, in the U.S., you don't run into this problem very often, but you know, there's plants in Canada that run at a different voltage than we run here and some other. So it's something that has to be watched and considered all the time. Rewind burnout procedures. Now, this is one I cover extensively in my training on motor repair is, you know, windings an electric motor, you send an electric motor in, and one of the things we have a bad habit of doing is telling the motor rebuild shop, I need that motor back as quick as possible. Well, there's a procedure on how you take the windings out of an electric motor. You actually put a core heater, you put it in an oven at 650 degrees, and you basically bake it for 24 hours, and then the insulation falls off the windings, and you can remove the windings after it cools. Well, if you say, I want the motor back in 24 hours, you know, one of the main procedures they use, they take an acetylene torch and they burn all the insulation off the windings to get them out. But when you do that, you unevenly heat that stator. The stator can come back egg-shaped. You can heat them up enough that the stator supports to the wall of the housing will break off. So lots of bad things can happen with improper rewind burnout procedures. Here's a motor here that's in the rewind process. You can see that they're bending their turns on their windings. And one of the things I look for when I do a motor shop audit is how clean is the facility. I was in one and down in Singapore, where they were rewinding, and the wire coming off of the spool was dragging across the floor as the guy was putting the bends in it, picking up dirt and dust, and the motor shop was really dirty. So I failed them within 5 minutes of being in the motor shop just for that reason, because this company was having trouble with the 5,000 horsepower motor failing in 8 months after the rewind, and there were just lots of bad practices. So it's got to be clean, and the coil wire's got to stay clean. Your rotor, constructed in many layers of laminated steel, consisted of bars of copper or aluminum alloy that are shorted with shorting rings at the end. But again, physical damage, taking the rotor in and out, imbalance. A lot of rotors are not balanced even properly from the factory. Broken or cracked rotor bars, contamination, improper installation can cause your rotor to fail.
Hey, Terry,
yes.
I've been with one more, again, kind of related to right now. What if you can't prevent a motor from being covered up with a product that acts as an insulator when on the motor?
Well, yes, sometimes you're going to have to put a bigger motor in, or you're going to have to somehow get some kind of cooling around it if it's running hot. But most of the time, I've been at plants where we put even covers over the motor to keep the product off the motors. But yeah, you're right, there are some cases where you can't do that, but as much effort as can be made as possible to keep it cool. Otherwise, you're probably going to be changing it a lot more often.
Okay, thanks.
Yep. But physical damage, very, very common. Here's a motor rotor that was damaged and shorted out. You can see the burnt spot in between the gaps of the rotor there. Imbalance. Now this is something where Toshiba and WEG motor, they're the only two that I actually know of that balance below the ESA standard. They balance down to less than 0.05 inches per second, where a standard motor is balanced in the range of 0.08 to 0.12 inches per second, which is okay. But when I was back at Cargill, we tested some brand new motors from Reliance that had never been out of the crate, and they came out of the crate at 0.28. They were 150 horsepower motors. Well, the bearings in those motors at that balance standard, those bearings will fail in 1 year. So again, if you have critical motors, and I know the nuclear industry does this, they check balance on all the motors that are rebuilt and have some standards, but something you may want to have that motor checked on a balance machine before you put it on to get long life. So the better it's balanced, the longer the bearings will last. Broken rotor bars, there's some new motors that use poor materials. I won't mention any of the motor, but some of your cheaper motors, they use some poor materials in their rotors, and you will get broken rotor bars. Now, expansion, when you have a motor that starts up and gets hot and shuts down and cools off, and it goes through a lot of startup shutdown processes, can also crack a rotor bar. But again, vibration analysis will pick this up. MCE testing and mechanical ultrasound can pick up cracked and broken rotor bars on an electric motor. Contamination, again, just like your stator, from chemicals, moisture that's in the area, poor storage methods. You get corrosion on your rotor bars and short them out. So again, issues you have to watch even in storage and in some of the areas. And I know everybody's got industries that they're in the fertilizer industry, where you have a lot of contamination from corrosion. So you have to be very careful with this. Better seals, Lapras seals on the front would help. Your motor bearings, how can they fail? Well, improper handling of the bearing, that could happen at the motor rebuild shop or at a mine. Improper storage, improper installation, and we all know about the effects of misalignment on motor bearing wear. Improper lubrication, we'll spend a little bit of time on lubrication. Over and under lubrication. Contamination of the lubricant is a key one. Overhung load. But improper handling of the bearings in storage, and this is one of the things I always look at when I help people with motor shop audits. How are you storing the bearings? I don't like to see them laying out on somebody's workbench before they go on. They should come right out of the box in the paper and go right on the motor and be covered up. But when I do my bearing training, a lot of bearings will fail on the shelf just from poor storage methods in damp and dirty environments. Improper installation, not using the right tools to check your tolerances. Bearings have to have a specified shaft tolerance and also a bore tolerance in the motor housing, so that can cause a motor to fail early. When you go to a motor shop, I've been at motor shops where they don't do this practice. Like, you can see the motor in the upper left-hand corner, the bearing's overheated. When that motor goes in for rebuild, there's a tool you use to check the inside diameter to make sure it's perfect. If it's not, it's got to be remachined and redone. So it needs to be checked to make sure it's perfectly round and make sure it meets the tolerance of the bearing that fits in there. So you always want to make sure that they're using that tool in every rebuild process. Misalignment, there's lots of training on misalignment, coupling misalignment, but you need to get within 3,000ths on all three planes after thermal expansion. But it says here, 3 to 5 times more life with precision alignment. Improper lubrication, and again, this making sure you're using the right grease. Electric motor grease is supposed to be a polyurea grease that doesn't have electrostatic properties, because in just every motor, the rotor actually builds up a charge, and that charge has to be released somewhere. So the easiest place for it to go to ground is through the bearing. So by using a proper grease, like a urea-based grease, it's less susceptible to go through the balls and rollers of the bearing. And this is especially important on motors that are driven by VFDs. You actually get more of a rotor charge on a VFD motor than you do a standard motor, where it has to go to ground. This grease cavity here, I always tell people, a lot of people don't grease motors, but when you grease a motor, you should fill it up here, take the bottom plug out to keep this cavity full, even if it's a sealed bearing, because it keeps contaminants from going in. I had to teach the mines down in Suriname. They had all their big motors stored in just lean-tos where they were getting wet. So we went out and took the plug out and make sure these cavities are completely full, so that moisture in those humid jungle environments doesn't get inside this motor. So it's just a good practice, and a good practice while the motor's running. Making sure you use the right grease. This is a mobile Polyrex grease, but any motor you use, it should be an EM-rated motor grease. It doesn't have those properties. Understanding what kind of bearings, I've done a lot of training on this because people don't understand what kind of bearings in the electric motor. I mean, some motors are coming with sealed bearings. Some motors are coming with shielded bearings, which means this seal doesn't go all the way to the edge, so grease can go in and out. Some motors are open on one side, closed. You have to ask your motor vendor what kind of motor I have in there. Then that'll help a little bit establish what your lubrication practices are going to be. So an example here, this is a shielded bearing. So the shield doesn't come all the way down. There's a gap here. So if the grease would get hot, some would release. And then just a major reason you want to keep this cavity full here, so some lubrication can flow back into the bearing. So understand the difference between a seal and a shield. Over and under greasing, this is what we're going to get in. This is where UE has helped so many companies with this problem with their tools. And I've been using some of their tools for motor greasing for years and years, but over and under greasing, very common problem. So like the over greasing part, make sure you take that bottom drain plug out so we know you can't push grease into the motor cavity. Here's a motor here that was over lubricated, where we pushed grease into the cavity. This was in a motor rebuild shop in Houston, and the guy's running around with a battery powered grease gun, greasing this motor, and the grease got into the windings and shorted it out. Here's one here where it actually caught on fire when the bearing failed. But you can buy these little reliefs. Now, my plan, I took the drain plug out and put a little 1/8" ball valves on the bottom of the motor to relieve the grease. These little stainless steel, I mean, this is probably 20 years ago, they were $3. They're probably $5 or $6 now, but you can put those in place of your plug. And then when you're greasing, this little spring pops open and lets the grease out. These come standard now on Toshiba motors, and I've seen some Reliance motors with these on the bottom side. So now this is a story here. This was a new maintenance person with not much experience. His instruction was to go out and take the bottom plug out and grease this electric motor until grease came out. Well, after one tube of grease, no grease came out, so he put another tube of grease in, and the motor shut down. Then you can see what it looked like when they pulled the rotor out, but again, not explaining things that if you get to 15 shots or 10 shots, stop, which is something that, when you do the UE training, you don't just keep greasing until that reading comes down, because sometimes it doesn't come down. So you have to use a little common sense there on that one, but this is definitely an over-greased rotor. But again, this tool here, I bought this back in probably the mid or late 90s at my plant, and immediately when we started greasing bearings and electric motors with this, our grease consumption went down 30%. So this is UE's 201 grease caddy, and you just put the probe on here and you just grease the motor till it stops making noise when it's got a high reading. Watch this reading come down to a point, and then when it goes back up, you should stop. But again, these are very good devices for lubing. They have the 401, which has an analog screen on it. But now they have they're on track where they're actually monitoring what's going on in this bearing all the time, and it tells them when this bearing is going to need grease. So again, get some training on this, because this is the future of lubricating bearings, especially on critical equipment for sure. So I just listened to a presentation on this a few weeks ago, and it's definitely what you ought to be using on your critical motors and critical bearings. Excellent, excellent system. Contamination, of course, one of the things that is nice about the auto lubers and things like that is we don't have to put a grease gun on there anymore. So a lot of critical motors that some of my customers, where they're out by the ocean, where there's saltwater contamination, there's a lot of dust and dirt or moisture around, we put an auto luber on there, and it puts the right amount of grease in there and keeps that cavity full. And again, going back to this system, you can do the same thing, making sure it's got the right amount of grease in the system. Overhung load, you know, and again, putting shivs and pulleys on there, you know, you're actually pulling on the side of the bearing. It's going to cause ball bearings to fail. But I always remind people that any motor of above 10 horsepower that you have a shiv, a sprocket, or something like that on, where you have side pull, you can put a roller bearing in the front instead of the ball bearing, and the motor's going to the bearing's going to last 3 to 4 times longer. A lot of people don't know that. They just change motors out and they'll put a bearing on a shiv operated motor, and the bearings will fail. So keep that shiv in. It shows here on the fan shaft, and it's the same on the motor shaft. Keep that as close as possible to the motor or the bearing. Reduce the overhung load. Bearing seals, you know, you can blow your bearing seals with over lubrication, improper installation. So again, be careful when you're lubing your electric motor that, you know, you don't have over lubrication type problems. Improper installation, again, if you're changing your own bearings in the field, and I even found one of these with my UE tool once. It was a motor that came back from a rebuild, 100 horse motor, and we listened to it right after the rebuild, heard some noise, some tinging in there, and the little bearing seal had actually come off. And we realized that the motor company, the rebuild company, didn't fill the cavity full of grease. So again, we had to send it back and get it fixed. The different seals, this is a Labra seal. A lot of your motors just have a rubber seal up front here, but you know, if you have environments where there's lots of moisture, lots of contamination, you can have Labra seals put on here. You know, Toshiba, Reliance, everybody will install Labra seals on your electric motor shafts. Bearing housing, improper installation, corrosion, that improper tolerance I talked about from wear. But improper installation, if you put that housing on, you don't get that right, or you don't tighten the bolts correctly with the right torque, it can cause that bearing to be damaged or to move around in that housing. You know, corrosion is a big one in some of these chemical plants, or especially fertilizer plants, where you get some moisture and stuff down in the bearing housing, and it actually corrodes that housing. And it's something your motor rebuild shop should be checking and correcting to let you know that, because once that bearing starts moving around in there, it's just going to wear it and make that bore larger and out of line. So again, make sure they have that tool I showed you earlier for checking and make sure that bearing's not floating in there. And if you have imbalance of the rotor, it's even worse, because the bearing will actually bounce around inside of that housing. Your motor fan. Sometimes we ignore this motor fan on the back, but this can cause a lot of failures of your electric motor, and it can be damaged from physical damage. You know, some of you people in the north, like we are, in cooling towers and stuff, ice build up on that fan when you're starting and stopping. That ice can break the blades off. Foreign material, corrosion. But the whole idea of this fan is moving air across that electric motor to cool it. And the cooler we can keep the electric motor, the longer the insulation in the electric motor will last. So here's one. This was one of my customers, and I was there, and supposedly the PM had been done on this electric motor the day before. So I took the maintenance person and the operator down there, and I showed them this. We read the temperature on the front of the motor, and I always read the temperature about halfway between the shaft and the top edge of the motor where the grease zerk is there. And we cleaned this motor off, cleaned the fan guard off, we cleaned everything off the motor, and the temperature of this motor dropped 35 degrees Fahrenheit. So what does that do for the electric motor? Well, for every 18-degree rise in the motor, you cut the insulation life in half. So we've more than doubled the life of the insulation just cleaning the motor. So ice buildup, corrosion, but here's your thing. For every 18-degree rise, you cut the life of the insulation in half. Your motor fan guard, you know, with plugging, this is one of the things I see in a lot of the textile industry, a lot of grain elevators, where you'll go back in and the back of the motor is plugged with dust and dirt and different things like that. I've got some thermal images that shows where the cooling air is not flowing across the motor. This can be an operator PM, keeping these, and it's not hard to do if you do it every week or every month. Keep that dust off there so you get good airflow across the motor. Very common I see in the industry. So again, It's a PM test that needs to be done to lengthen the life of your electric motors. Now, this is a motor I took a picture of in a motor rebuild shop. You can see this motor's all rewound, getting ready to go in to be baked the insulation on, but we can see I probably, if it had been my motor, I wouldn't have rebuilt it because there's some pitting and damage on the stator, which is going to cause some inefficiencies. But again, it's the question, how often or how many times can you rewind an electric motor? And again, it depends on the condition of the motor and what processes are used to rewind. If they use good rewind procedures, you can still lose 3% efficiency on the motor. So after you've rewound an electric motor 3 times, it may be 9 or 10% less efficient. And it may be, from a cost standpoint, may be more economical to put a new motor on there that's more efficient from an electrical cost standpoint. But again, you have to tell your electric motor rebuild shops, of course, they're going to rebuild them as many times as they can because that's how they make a living. But you need to set some specifications on there. One of the specifications I always tell people, when you send your motor into the electric rebuild shop, they should balance the rotor to less than 0.05 inches per second. I don't care what kind of motor it is, whether it's a Baldor or a Dayton or any of the cheaper brand motors, balance that rotor to that lower standard and your bearings will last much, much longer. Your motor insulation and windings. So here I combine these two together, but contamination, overheating, improper storage, moisture that gets in there, insulation breakdown, cycling and flexing, and AC drive stress. We've talked a lot about contamination from some industries, moisture. So again, we have to watch this one and keep that cavity full so the stuff can't get in there. Overheating, again, this can come from just your fan not working, maybe an external source of heat around it can cause our insulations to fail. But again, every 18-degree rise, we cut our insulation life in half. I put this chart in here again for your general reference, but a lot of electric motors, your cheaper electric motors, come to you when they're brand new with Class A or Class B insulation there. When you rebuild the electric motor, have the motor rebuild shop put Class F insulation in. Toshiba's come standard with Class F insulation. Or if you have high temperature applications, you got Class H, but you can have the motor rewound at just not every instance if there's room, but in just about every motor, you can go to Class F insulation and extend the life of your motor, especially if it's running in hot areas or you're having trouble keeping that motor clean like somebody brought up. When the motor's rebuilt, use the Class F. Now, Cargill standard for every motor that's rebuilt, they put Class F insulation in the rebuild. Improper storage, we talked about that. Temperature swings at the plant I came from. Of course, we didn't have any inside ambient place to store big electric motors, so they were in an outside warehouse that could be -20. This time of year, it could be 120 in the winter or in the summertime inside that place. So the motor's going through big temperature swings in storage, and you can actually pull moisture, get moisture into the windings and cause failures. Here's one here where we have a hot spot on the side of the electric motor with a thermal imaging spot here. It's good. So this MCE tested and infrared will detect some of these potential failures. Now, this could be an issue in the future, but it's something we can watch. Cycling and flexing. So one of the things that FLIR had a very good drawing or a very good video of a few years back that I saw, I couldn't get a copy of it, but when an electric motor starts up, the interns on the electric motor, the interns of insulation, they actually move as the motor comes up to speed. So the more times you start and stop that electric motor, the more chance of wearing the insulation off on these interns. So these actually move a little bit as the motor comes up to speed. Now, the exact same thing happens with variable frequency drives. And variable frequency drives nowadays are what's called pulse modulated. So they send pulses of voltage to the electric motor. And as that electric motor is receiving those pulses, these interns are actually moving. And so that's sometimes why people say, well, if you're going to have a VFD on the motor, make sure you get a VFD rated drive, which has usually extra insulation or it's a next size bigger motor, but VFDs will actually wear the interns out on your insulation. So again, something to remember. Here's a motor failure breakdown, and you can see, look at this here, bearing failures are 51% of motor failures, which if you look at misalignment, if you look at balance, and we look at lubrication, we can eliminate 51% of motor failures. And then stators and windings, we talked about a few of those things, rotor bars. There's a few unknowns, which could be storage. And so lots of different things here, just looking at this chart. But remember, if bearings are 51% of motor failures, we got some information today on how you fix that. So some slides here, preventive maintenance for electric motors. Grease motors as needed with a proper rate of grease. Now, if you need, I can send you a little chart on the recommended, well, what the manufacturing recommends for relube frequencies, but again, there's a lot of factors. In fact, I wrote an article, and I think UE has it on all the different factors that affect how often you should grease an electric motor. There's about 20 of them. And that's something that you can check with them on it or shoot me an email, but I like to get that in everybody's hands because everybody thinks that, well, I'm just going to grease my motor 2 shots every month, but there's a lot of conditions, you know, whether it's moisture, temperature, balance, load on the motor that's going to affect how often you lubricate. If you have big motors that have oil lubricated bearings on there, like on a big ID fan, change that oil often or get oil analysis. Now, usually there's not enough oil in there to warrant oil analysis, so I just tell people to change it more often. Because a lot of times it looks good in the little sight glass and bulb, and it's not, it's dirty. What does this mean? Perform hands-on inspections weekly. That's one of the things I required my operators at my plant to do. I said, put your hand on that electric motor every day or every week for vibration, for temperature, and to make sure I've got good airflow across that motor. So that was one of the main things they were checking for, is the fan blowing airflow across the motor and is the motor clean. Store your motors correctly away from moisture. And of course, keep moisture and chemicals away from motors if you can. Precision maintenance. It says always align motors to under 3 thousandths in all 3 planes and eliminate sawfoot. Always specify precision balance on your rotor. So like I say, when you send your motor to a motor rebuild shop, you have them balance that rotor to 0.05 inches per second or less. Now there's a lot of motor rebuild shops, and they're supposed to do this on every rebuild, is check the rotor balance. It's usually not done because we're asking for it to come back real fast in a lot of cases, but give them that as standard. So 2 of the standards we talked about today was make sure you get precision balance on the rotor, use your class F insulation in the motor when they're doing the rewind, and then make sure they're checking that bearing board. So use certified motor rebuild shops, you know, and sometimes you have to make a decision. Am I going to buy a new motor, and we're going to rebuild it? I know Cargill, before I left Cargill, that any motor under 50 horsepower, we didn't rebuild, we threw them in the dumpster. I was at a couple refineries in Texas where their number is 100 horsepower. So if 100 horsepower motor fails, it goes in the dumpster and they put a new one on. Now, most of us can't afford to do that, but we have to still make some decisions. You know, you shouldn't be rebuilding them, rewinding them more than 3 times. Now, I wrote an article for UE back in the 80s where I had a 7-year stretch when I started using the UE tools where I didn't lose a single motor at a pretty large facility for 7 years on emergency downtime because we read the bearing readings on our UE tool every month, and we took the motor out and had the bearings changed when the bearings got to a certain point. So we had a 7-year stretch at a plant in Ohio where we didn't lose a single motor on emergency downtime for 7 years. And it was a pretty large facility. So there's something to be said for proper testing with these UE tools. Predictive maintenance. There's all kinds of ways to predict motor failures. You know, one of the real good ones is motor circuit evaluation. You know, a company like that sells this stuff, you can find 100 different things wrong with your electric motors with just this one tool. Vibration analysis picks up a lot of motor failures. Mechanical ultrasound, the new 15,000. I mean, I'm amazed at all the things you can pick up with bearing faults and rotor bar faults and some electrical faults with the mechanical ultrasound tool and electric motors. Amazing technology, some of the new stuff you can do with that. If you have sleeve bearings where you have oil, you know, make sure you use oil analysis or just filter and change that oil more often. So lots of things in the precision, predictive, and preventive maintenance area for our electric motors. Some proactive maintenance. You know, what do I mean by this? Purchase precision motors for critical applications. So what do I mean by precision motors? Well, you know, in Cargill, we found out Toshiba has these better balance standards and better insulation standards. When we did our asset criticality in our facilities, we put Toshiba motors in the top 20% of our critical equipment because those motors were better motors. They were going to last longer due to their construction. Now, I shouldn't tell anybody you don't want to put Toshiba motors on everything because you have motors that aren't going to cost you much if they fail, but precision motors for critical applications is key. Certified motor rebuild shops. You know, Cargill certified a bunch of motor rebuild shops back in the early 2000s because we were finding out we were getting motors back that weren't rebuilt properly. So we did some motor shop audits. I've done a few motor shop audits for people, but there's companies that do that for a living. Again, this comment, make sound decisions. Should I rebuild it or should I just buy a new one? Use precision maintenance. Every time you put that motor on, a lot of times in the reactive mode, we don't use precision maintenance. We don't do our precision alignment. We don't do our precision balance. Precision lubrication, making sure that grease zerk is clean if you're going to keep greasing it with a grease gun. I've got, I don't know how many pictures of dirty grease zerks on electric motors and cement plants and other areas where you're just pumping particles into the bearing, especially if they're open or shielded bearings. And then, of course, like we talked about, all the new equipment that UE has out there to make sure we get the proper amount of lubricant in the bearing at the right frequency. That's key, not just going off of some chart that the industry's put together on give it 10 shots of grease per month or 10 shots per week. There's so many factors. But if we have these tools to tell us when the bearing needs lubricant, that's what we should be doing. So again, I went through some of the slides pretty quick, and it looks like might be 5 minutes ahead of schedule here or more, but a lot of information on electric motors. And again, we have some other information if you need it, but are there any other questions from anybody?
Oh, yeah. Oh, yeah. It's good that you wrapped up a little early because there are quite a few.
Okay, good.
So we'll just start kind of rolling through these. And if we don't get to all of them, or if we don't ask yours because it might be a little more specific, I will for sure be getting these questions to Terry, and he can follow up with you, after we're all wrapped up. So, all right,
I've got till 6 o'clock, Maureen.
Oh boy. Okay. Well, good for you. I don't think kids can be quiet for that long, so we're gonna have to not stay on that long. But okay, so here we go. We'll start hammering these out. So, what are some? And of course, you maybe have kind of answered some of these, but you can kind of reiterate. What are some lubrication best practices for motors that have greasable bearings, do not have a drain port on the bearing housing?
Yeah, those are really tricky when you don't have the drain port, because eventually you're going to put grease into the motor cavity. So you just have to be real careful. And this is the real important point about using some kind of tool like the UE system, so you know when to stop. So if you don't have a drain port and you're just going out there giving it 2 shots or 5 shots, over time you're going to get grease into the motor cavity. And many times with the UE tool, you'll find out it doesn't need grease more than once every 3 to 4 months. So make sure you use the right tools is the key to that one.
All right, and kind of on the same line, what about encapsulated motors that you can't grease?
Yeah, those they're doing a lot of that now with motors that are inside of a can or something like that. So those they put sealed bearings in those, and your bearings are going to last as long as the grease in the bearing lasts. But if the rotor's got good balance, I always tell people this: if the rotor's balanced properly, there should be no load on the bearing because the rotor should be floating in that magnetic field. But yeah, I can't give any suggestions on motors, encapsulated motors.
All right. How much grease should be added on brand new motors?
Well, in theory, none. But you're going to have to ask. Some motor companies pack that housing in the front. There's some motor companies that just put some grease in the bearing and leave that cavity open. So on brand new motors, and I was going over this with the mines down in Suriname, that just take the drain plug out and put some grease in there and make sure that cavity's full. And it's real easy on new motors because the grease will come out pretty easy. On old motors, sometimes it'll be dried and doesn't come out very well, and you can cause problems that way. But on new motors, I would pack the cavity, especially if they're going to be in storage for any length of time.
All right. Is it always the motor that causes soft foot? Sometimes the mounting plane is not perfectly flat.
That's correct. And a lot of you go into plants and they're using those old standard channel bases to mount motors on. So sometimes it is the base that causes is actually could be more of the problem for soft foot. So, I know in Cargill, when on all of our big motors, we put brand new bases under all of them that were made out of really heavy metal. Like the base of your electric motor is supposed to be within 75% thickness of what the foot thickness is, and you see that very, very little in the industry. So that, yeah, the base can cause a soft foot problem.
All right. This gentleman works in a paper mill and says we run a lot of motors around wet cardboard like a pulp. And when it gets on the motor, it hardens from the heat of the motor and then keeps the motor hot. Any suggestions other than guards around the motor to assist with this problem?
Yeah, and I was at a cement plant where you have the same problem where they get cement dust on there and it bakes on there. And we actually took some galvanized and on the motors outside and put galvanized over the motor and gearbox to keep the cement dust off. Paper mill's a little, there's some tough applications in a paper mill where you have a lot of moisture and things like that, but it's just either covering them up and keeping them protected or doing a, more regular cleaning of the motor. But again, paper mill industry is a tough industry on electric motors.
All right, sorry, they're just kind of flying in here, so I'm trying to read them all. What's the best way to search bearing type? Is there like a database for kind of your average Joe to look for sealed, shielded, regular bearings? Do you have any suggestions on that?
Well, I kind of base that on the industry. In industries where you have a lot of moisture, where you think you're having bearing issues or bearing failure issues from moisture, I go with sealed bearings and then still try to keep the cavity full. But there's no good information out of the industry on that for sure. I like bearings that you can actually get some maybe shielded on the back and sealed on the back and shielded on the front, so we can actually have some lubrication that moves in and out. Because I found this a number of times with ultrasound tools, if you start greasing a bearing and you're listening for the ultrasound frequency to change, and sometimes it doesn't because the grease isn't going into the bearing. But I've had some where you start hearing a little knocking noise, and it's actually you're pushing the seal or the shield into the bearing and it's tapping on the balls as they go by. So, but the type of bearing that you get, you just have to ask for and sometimes specify what you want. But again, going into motor rebuild shops, I've seen a lot of people going to sealed on the back side and a shield on the front side as their standard.
All right, can you grease a motor when it's not running if you're not able to catch it during runtime?
Yes, you can. You just have to be more careful. Of course, ultrasound's not going to help you there, but that's where you want to make sure you can take the drain plug out so you don't push that shield or sealed in, or you don't push motor grease in there. But a lot of your new motor specifications coming out on the little tag say that you should grease a motor when it's not running and locked down, but that's not the best time. But that's happened because of some injuries they've had in the industry with people getting their hand caught around the shaft or a shirt sleeve or something. So, but the best time to grease is when it's running, but you just have to be more careful when it's not running to make sure that grease, the extra grease, is coming out.
All right, thoughts on food grade grease?
I'm gonna make some people mad on this one, but yeah, food grade greases normally aren't as they're not as good as mineral based greases. For one thing, especially in hot or wet environments, because with hot environments they oxidize and dry out really fast. Some of them don't mix with water very well, but some of the new synthetic food grade greases are better. Still not up with petroleum based and regular synthetic based greases, but you have to, I always tell people with food grade grease, you have to increase your lubrication frequency if you have any temperature at all, because they do oxidize a lot faster.
So I'll throw in another plug for, and if anybody wants a direct link to it, but Terry has done several, webinars for us, of course, throughout the years, and we've got one on file where you talk about lubrication selection and storage best practices. So you cover a lot of that in there. So if anybody wants a link to that, just shoot me an email, which we'll have that up at the end. Okay, and I promise someone is asking this, but we have guarding and blocking issues on our where our grease fittings are. Is ultrasound still something that you can use in that situation?
Oh yeah, I just recommend ultrasound on it, especially if you can't get to that grease plug. You should be using some kind of ultrasonic device to tell you when to stop or if the bearing actually needs grease. And I know me and Justin were at a plant doing some work, and we we were training them on the UE tools to set their baselines, and we actually ran into some of that where you can't get to the drain plug, you can't get to the greaser very well. So there's those issues. Those have to be engineered out at some point if you want to have a good program, but I know those issues are there.
And a couple people asking about auto lubers, and of course, what your thoughts are on those. So maybe you can just touch on that.
Yeah, well, I've done quite a bit of research on this, especially when I was at Target. We tested all the auto lubers, the types of spring-loaded, the gas cartridge, and the battery-operated ones. And the ones that work the best are the battery-operated ones, that, especially in temperature extremes where the temperature may change in that area. So the battery-operated, where you can, but the key to that is the way we used them. We used our Grease Caddy 201. And we over the course of a month or two, we figured out how much grease the bearing actually needed and what the frequency actually was, because we had some bearings that were greased weekly and monthly, but we found out that some bearings needed grease at 5 days, some bearings needed grease at 15 days. But once you figure out your volume and frequency, that's where the auto luber becomes very, very beneficial, because now you can give the bearing the right amount of grease. But it does take, to me, it takes an ultrasound tool to figure out where to set the auto luber correctly.
And to that point, and I'll have it on a slide here later, as Terry alluded to in his presentation about our latest technology, the OnTrack Smart Lube, we will have a presentation on that at the end of the month to kind of wrap up our Lubrary. So for those interested in that, we'll have more information. And of course, you can always email us also if you want to learn more about that. So that's cool. Okay, let's see. We'll do a couple more, and then, like I said, if we don't get to all of them because they're flying in, we'll follow up with you all after. Do you have recommendations when it comes to VFDs?
Well, lubrication-wise, no, but recommendations for VFDs is you need to make sure the motor is rated for it's a VFD rated motor if you can, or if you change it out or you're going to add VFDs. But, you know, VFDs, the only real problem with VFDs is, well, there's not a real problem from a lubrication standpoint, because most of the time they are running slower, but that creates a problem with ultrasound, because when you try to ultrasound a VFD motor that's running maybe down at the 25 or 30% range, you pick up the pulses. And so a lot of times you got to figure out how to use your tool to be able to filter out the pulse from the VFD and actually hear the bearing. But sometimes they get so slow you can't get a reading on the UE tool. So there you're just going to have to use some common sense of lubrication, or take that drain plug out and just keep the cavity full.
All right. Couple people seemed kind of intrigued when you were talking about like the certifications for the motor motor repair shops. Do you have, like, is there any kind of standard for that, or a place where you could kind of find like what an audit of those shops would look like?
Well, yeah, I have a motor shop audit. I have a form that I can send people, or I can send it to you and you can pass it around, where they can just ask those questions and then some of the specifications. But it's basically the form I would use if somebody asked me to go look at their motor shop. So I can actually send that to UE, and then if you can send it out to anybody you want to, because when you walk in the motor shop, there's certain things you should look for and ask for, and then there's specifications in the back of my motor audit that you should tell your motor shop you want them to do, like the balance standard and the insulation standard and some of the other things they should be checking. Or you can hire me and I'll go do it for you, but the easiest way is to.
Exactly, there you go. So, okay, cool. Well, a couple more just to kind of answer, because several people asking. So the presentation, we have been recording this, so we will put it up on our YouTube channel. If you want a direct link to that, just shoot me an email and I'll make note to send it to you. Otherwise, when you go to YouTube, you can just search up UE Systems. We've got a whole channel with all of our webinars, including the ones I was talking about that Terry's done in the past on the lubrication selection and storage best practices. So you can find those there, or shoot me an email and I can direct you to it. As far as a copy of the presentation, Terry, is that something you're willing to share your slides?
No problem. Do you want it in the PowerPoint presentation form, or you want it in a PDF?
probably best to send it as a PDF. But if you want to send me both, and then folks, you can email me and I can share that with you. Or of course, Terry has shared his contact info, so you can always reach out to him as well. But that's cool that you're willing to do that. Not all presenters are. And so, yeah, so again, if we didn't get to yours, we'll share all these over to Terry so he can follow up with you. And if you asked kind of more of a specific UE systems question, of course, we'll follow up as well. So just to kind of wrap up, obviously, thank you, Terry, so much. Awesome information as always. So definitely, guys, go to his website and he's got a ton of resources there, and check in with us on articles and webinars that he's done that we've got access to as well, so you can continue to learn on this topic. As we move throughout the month, next week, we've got Spectro Scientific, or actually Amatech now, I believe is their new name. They are going to be coming on and presenting on using on-site oil analysis to drive down maintenance costs. So that'll be cool. We'll be getting an invite out for that tomorrow. And of course, we'll have the registration link up on LinkedIn as well. And then, as I stated a little bit ago, at the end of the month, we'll wrap things up with a OnTrack Smart Lube product demonstration and presentation, so you guys can learn more about how we are utilizing ultrasound and auto lubers to provide precision lubrication from anywhere, anytime, literally from your phone, from your computer, however you want to do it. So we're really excited about that. And I think, as you learned from Terry today, using ultrasound as a part of your lubrication processes is really critical. And we're, always working to find new ways to make that work even better for you all. So definitely check that out. Hit me up if you've got questions about that ahead of time, but we'll have registration links for that out here soon as well. And as I mentioned, just keep an eye on our LinkedIn page as well. Again, we'll share out a ton of information throughout the whole month on these topics. So with that, I'll leave our contact info up here so you can know how to reach us. And Terry, again, thank you so much. Really appreciate it. Thank you to everybody for spending some time with us today. And we will catch you guys later.
All right. Thanks, everybody.